Okay, so I think we can start with small delay, but after all, we've got the room is full, so it's perfect moment to start. So the topic of this discussion panel is SQL versus no SQL. Is the war over? Maybe not, maybe yes, we will see. So we've got three panelists today. We've got the Michael Hanger from Neo4j, the head of developer relations. We've got Robin Moffat, developer advocate at Confluent. So you know probably these guys from Today Morning Talks. And finally, we've got Wojtek Tak, which is a CTO of Freshmate, the company based in Krakow. So three very, very experienced guys. So my role is today just be humble moderator. I will try to moderate discussion. We've got a tab to speak for you. So please visit this URL, tts.sc/pdci. And on this page, you will see a form when you can submit your question. Your question will not show exactly in the moment of publication on the screen, so I will moderate this discussion. On this URL, there are many tabs, so check all of them. Under some tabs, there are some votings. We will publish this voting in different moments of the time, so we will see, for example, how much of NoSQL adoption we've got in the room. So please visit this URL and submit your question. So the first question is from me to start discussion. So this is just one question. So I remember that a couple years ago when I was fascinated by Neo4j, by the way, I made a presentation where I submit my 90+ hypothesis. What is the 90+ hypothesis? From my experience, it seems that you can read it? Sure. So, my problem was that for every single developer in the set of developers, there is no such data structure like graph, set, list, whatever, that cannot be expressed with SQL. So, because the SQL is a language, for example, I think every single man, every single woman in this room has ability to speak SQL, so we can use this language for anything. So my question to you is, do you really need any other solution than SQL? Because I can express everything in SQL. For example, for data structures.
Hello?
Yeah, it's good.
Cool. So SQL is a declarative query language. And so it's basically limited to what it can express on the language level and limited to what the underlying database can handle, right? So if your underlying database can handle all these data structures, like imagine JSON in Postgres or something like that, then I think it's fine. If you want to express this only on the language level, you will see that it's getting cumbersome really quickly. So for instance, if you want to do an arbitrary length path or a tree or something like that, in pure SQL, you can do it with common table expressions or something like that, but then it's only like 5 or 10 people in the world that can actually write it, and perhaps 50 that can read it. So it's not as easy as it should be, right? And so that's why there are other languages for databases that add these capabilities, or there are a lot of SQL dialects actually, like KSQL for instance, or like SQL squared, that actually add support for trees and documents and lists and sets and all the other operations that are commonly used today, but were not commonly used back in the day when SQL was invented, because it originally was invented for storing forms, right? So not even connections, but storing paper forms in tables, basically. And that's what it was built for back then. And as I said this morning, in the SQL standard, there's much more than actually is implemented by the vendors, and the vendor implements much more than the standard. So there's basically a certain overlap where they both are okay, but then there's like a lot of stuff in the standard and a lot of stuff from the vendors, and there's no one SQL to say so, right? So there are lots of dialects which all have their individual extensions and so on. So it's plain SQL, I don't think that you're right, but with like extended SQL, then you can do anything.
I think for me, SQL is kind of like the default starting point for accessing data. Like you say, everyone knows it. But And so then extending it where it makes sense, so like with KSQL, to add in streaming capabilities, it fits in the syntax, it fits in the grammar. In trying to articulate what you want from the data, it makes sense. But when it gets too convoluted, I don't think we should be dogmatic about it. I think things like Cypher, where actually there's more elegant ways of accessing the data which just doesn't fit with it, makes sense as well. So I think it's kind of best, whatever's best for the job at hand.
Yeah, so I would look at it from a different perspective, being responsible for the team and for the company. I would say from our perspective, SQL is probably the best choice because everyone knows it, as you just said. And from my perspective, what we've seen over the last years is that SQL, well, of course, there was this big NoSQL movement, but there was on a technical level. From a perspective of what can be done, we've got now SQL to query streams. We've got, so both in Kafka and Flink, for example. We've got SQL on Spark, etc., etc. So we're getting more and more adoption. And also, you've got SQL in MS SQL that supports machine learning as well, slowly. So I think that we have the much wider things that we can do with SQL. And from my perspective, this is really great because you don't have to teach people anything new. And it's simple. This is what they know. And this is very important from my perspective because knowing SQL, I can do pretty much everything. So typical SQL, as we think about that, that's a database that have data on rest. So whether it's MySQL, from MySQL to Hive, I can just do the batch. But I can also do some stream analysis, which is very powerful. Amazing tool for quick prototyping, I would say. And also, we are entering a world where you can do machine learning with SQL. So, from my perspective, this is one tool, one language that you can use to do absolutely different stuff. And when you think from the alternative is, of course, you can have a SQL database. You can have something for your streams, something for your search, something for your whatever and whatever. And we can have different query languages for every single tool or low-level APIs. But imagine the hell of the team and support and maintenance and development. And we're about making things very rapidly, and making some very quick innovations, just exploring new ways, new areas. And this is where actually SQL and the adoption of SQL in those technologies is really helpful from my perspective.
Okay, so from your perspective, from your experience, which of the limitation of SQL databases is most problematic or annoying for you? From your perspective, the biggest limitation of SQL today?
Which database?
Any SQL database.
I think from my perspective, once you get into really advanced topics and really advanced data analysis, sometimes SQL can be hard to read because you will enter the world of 4-page long queries. And being able to analyze them easily requires a lot of experience. Not only building them requires a lot of experience. So again, this is, I think, a little bit of a pitfall that we can get into.
Yeah, I'd agree, really. My background's solidly in data analytics, so I've always worked with SQL, complex 4-page queries, but I suppose for analytics, for that kind of stuff, I've not really come across anything better. It's just like, it's complex when it gets complex. The one time I have found like SQL's not really fitted is when I dabbled with some graph, and so then that's where Michael comes in.
Yeah, exactly. So that's where I also saw the biggest drawbacks, and that's why Neo4j was created. As I said this morning, we tried to build it with relational databases, but didn't work, and that's why we changed kind of how the storage approach worked and under the hood for graph operations, right? So that was one. But I could also imagine these relational databases don't deal so well with streams in themselves, right? So they have the transaction log, which is a stream, but otherwise you can't really access the transaction log as a stream, right? So that's also something that might not be so easy on a database level. But I think in this panel in general, we should differentiate between SQL, the language, and relational databases as implementations, because there are more databases that support SQL than just relational databases. And actually, what you just said, actually we already have the situation, right? So if you have a larger architecture, you have Mongo with Mongo's query language, you have Elasticsearch with Elasticsearch query language, you have Kafka, you might have Cassandra instance, stuff like that, or Couchbase, right? So, and everyone that has Nickel, everyone has its own, perhaps SQL dialect, but Mongo has, for instance, completely different query language, right? So it's actually, currently you have this kind of proliferation of query languages, and that's kind of the current situation, and it's interesting to see where it goes, because we've seen that Elasticsearch added SQL support recently. Nickel looks quite like SQL. Let's see what happens in Mongo, right? There's also some work there, so that seems to be something that's really interesting as well.
We've got a problem because we all agree.
This is what I afraid. Okay, so we've got a question from audience, from Robert. It's easy to put data in database and get it back, but it's hard to get a stream of changes from DB for processing. So why don't database can expose it more often via log?
So the stream of changes from the database, as I mentioned in the talk, for anyone who came to it, the change data capture, getting it out of the transaction log and into somewhere like Kafka is the obvious way of doing it. And different databases have different streaming APIs. So like Oracle's got the XStreams API that you can kind of build against if you want to. But I think that's where, and certainly in my experience, database is about working with static data. And any kind of streaming capabilities are an afterthought. So that's where something like Kafka and other streaming platforms come in, where it's actually reasoning about data as a stream of events and actually going back from a table as like your base unit or a row of data and actually an event. So an event is a notification that something happened and also state transfer. So if you reason about your data as events, and I believe all data is events, and then decide how you want to model it. So it starts off as a stream, and then do we want to persist it to a database? Do we want to persist it somewhere else for the purposes of reading it? But starting off with it as a stream.
I also think transaction logs are usually implementation details, and kind of, if you build something like database, you don't really want to expose your inner guts to the outer world, right? So you either have to build an API, or you have something like Golden Gate in Oracle that you have to pay for a lot of money, right? And so it's something that's not easily accessible. Something actually I found, I just thought about, how is it actually dealing with more complex operations? So imagine you have a relational database, you do a transaction that updates 7 tables or something like that, right? How are these brought together into 7 events or 1 event, or how do you figure out how this stuff goes together? Because each event individually is actually not consistent in itself, because it could be like just a join table update without the other 2 updates from the other 2 tables having yet arrived, something like that. So that would be an interesting aspect as well of, if I just expose the transaction log, how do I get the consistent view of stuff back that I had when I ran it?
Yeah, and that's usually an implementation based on the change data capture tool. So like Golden Gate has an option, only send over committed transactions, or I'm sure Debezium has similar. So then do you actually want to do a dirty read and get just all the events as they happen, or do you need a consistent set, like you say, for doing joins between multiple different tables?
I can only add that question. I think this is really pointing the mindset that we have the data at rest. That it's easy to put that data into the database, but when we're entering the world of event-driven architecture, what is putting the data into the database if not the stream of data, and then a stream of events, and then actually probably we need a different paradigms and different ways of working with the data. So yeah.
It's actually an interesting question, right? So if you look at things like the Spring Data initiative, right, which is NoSQL integration for the Spring framework, or database integration for the Spring framework. And all of those are mapping directly from your objects to the database. They're not actually mapping from your business operation to a stream event, but they're always mapping from, so is this wrong? Does it mean like Spring Data is kind of the wrong approach? What would you say, or how would you build an like middleware application that actually doesn't do that? Would you?
I wouldn't say it's wrong. It's just a different way of modeling data, and it was working for us for a long period of time. But as you enter I think it depends on really what you require. If you can work with the large data sets, or maybe not even the large data sets, but data that is basically speaking batched kind of a data, you're fine, and this is perfectly okay with you. But when we're entering the world where business require immediate actions, rapid actions, swift pivoting of business processes, etc., and then when the time counts, we don't have that luxury of having objects being written to our databases, so we can read them, analyze them, etc., etc. We need to do that on the stream, on the fly, and write, of course, a copy of that to our databases from the stream. So this is a typical PubSub architecture, which I'm a huge fan of. So,
how do you actually constitute a view of the world if the rest of the world is not in the stream? So if I use KSQL, for instance, okay, I have my events in my topics that I can join and pull together, but what happens if like 90% of the data is still out in some databases that are not pulled into the stream yet? How do you deal with that you get access to this data as well for your business decisions, for instance?
Again, that's just where change data capture comes in. So what we see quite a lot with Kafka is that people aren't entirely convinced at first. They'll be kind of like a team that kind of gets that this is a great idea, but the data, as Michael says, is like it's here, there, and everywhere. You've got your own data that you're responsible for, but you need customer information, you need product information. So integrating the databases in is kind of like simple enough. You just change data capture feed out, and then you've got that data. And then as people realize that, oh, hey, Kafka is actually a really awesome platform against which to build, now my application that's writing that customer data or whatever, I'm going to write it into Kafka, because you see that I'm going to benefit, they're going to benefit, and you start moving away from this idea of we'll use the database as the kind of the standard place for writing stuff too, and then having to fall back on, well, we'll just change data capture it out into Kafka so that other applications can use it, to actually applications producing their events directly to Kafka.
So actually is Kafka the new data lake? Or the data stream or river or whatever you call it?
It's definitely not a data lake. Data lake, I know I was a bit rude about them in my talk, but data lakes are perfectly valid, but this mindset that I've seen in some places where you've got data and you used to write it to a data warehouse and now you write it to a data lake, from where everything else grows, I think is flawed, because it's this idea you're going to take your data, we're going to write it down there, and then we're going to pick it up and then do whatever with it and do some other things. Actually using Kafka as a platform, as a streaming platform against which you build your applications, including data which will then feed down into your data lake, but also a bunch of other places, is much more the mindset around it. So definitely it's not the new data lake at all, but it's the new platform against which organizations are building a lot of their applications and systems.
Okay, so thanks for your question. I've got plenty of them, but I'm asking for more questions. So we've got an interesting topic. In highly evolving environment where NoSQL might be a solution providing flexibility, how to avoid mess for inconsistent models around the system?
Model the data right.
I guess you can't avoid mess. Reality is messy, data is messy. You can't avoid the mess, you can only make the best out of it, basically. Right? You can't, I mean, you probably know of these kind of big golden record initiatives at large companies that say, now we're gonna create a real consistent data model of the whole organization, right? So, and it took us like 5 years with 50 departments to model this. And then we acquired another company and we had to start again. And basically, if you do this one model of the whole picture, then it's seldom a good fit for all the other departments. It's like something that perhaps the manager wants to see on the top of the company, but it's not really useful for that. So that I would say rather use something like bounded context where you have individual per use case or per department specific data models and then exchange data between these models. Otherwise, it's impossible to achieve, actually, I think.
Maybe not even department, but context, business context. Yep. And then if you have the single source of truth for every context, you're doing it well. Yeah. And
I think one of the kind of the lessons that is being relearned now is that you chuck everything away and burn it to the ground, but there are some things which matter, and one of them is the schema of your data, is the model of your data, and things can go too far one way, and you try and model everything before you build anything, which is patently ridiculous and didn't work. But similarly, thinking that we can get by without modeling the data or just kind of like winging it, that's going to come home to roost. So you have to take responsibility for the data at some point.
So I guess we really wouldn't care what is the database as long as we have the consistency of the whole context. So whatever you use, SQL or NoSQL, that's fine.
I suppose that's the interesting thing about NoSQL, because it let people get away with being agile or flexible or lazy, if I'm allowed to say that. So kind of, whereas if you have a relational system, you have to think about your schema. Even if you just say, oh, everything's a varchar, at least you said, I've got these columns. You've put in a bit of thought about it. Whereas if you can just chuck any data in there, I think it's probably easier to screw things up. Which isn't to say people shouldn't have that option. I'm not being kind of like a nanny state about it, but I think NoSQL gave people that dangerous option of being able to not think that it didn't matter.
Actually, an interesting anecdote. Back in the days when I was still working like in enterprise applications, there was this, in Germany there's this EDI format, like electronic data interchange, and which basically specifies interface tables which have columns like AA or A24, C or N26 or so, which is an alphanumeric with alphanumeric column with 26 characters, a numeric column with 12 characters, and so on. So they kind of completely underspecified the format because they said, okay, all these hundreds of thousands of suppliers that need to shuffle in their data, they can't agree on a standard. So we just slap on like 100 extra columns for arbitrary data that are actually specified by the data format, the name of the column, and not by like any meaning. And so, and of course they used it, right? There was so much data in all these anonymous columns and much less kind of clean data because it was too much effort. And so data cleaning and data provenance is a horrible effort if you have to deal with that. So it's something that we paint quite a lot about back then.
Okay, sometimes we've got a greenfield, a project you can start from scratch, you can make your own choices. So maybe it's a moment when you can switch your concept how to store and process your data. So what factors should be taken into the consideration when we are trying to figure out which database should use in the system? Or, for example, another question, when creating a new service, how to decide which database should I use?
I would say
because
whichever...
the hype is there.
Yeah. I would say whichever is good for the team, which is known, easy to maintain, easy to extend. So if it's a cloud, go for it. If it's MySQL, go for it. If it maybe not a big Microsoft Access, well, if it delivers... Guys, I think someone has seen some amazing stuff done right? I've seen some amazing stuff done in a pure Excel. So I would say, if your team is comfortable with modeling your business and do it really well in Excel, and delivers whatever the goal of the project is, why should we matter? Why should it matter? And it's delivering the business value. So, for example, if it's a prototype, that's okay. Apart, I've seen on the production where a very known company actually was this kind of a solution using Excel, not Access, was actually was part of a very critical system. So maybe it wasn't the best solution. But actually, they kept all of that in email, so it was really well backed up, if you think about it. Yeah, they had their own version control.
Yeah, it's kind of the shadow IT that builds around systems. So I would say usually you look at volume, you look at like how up to date the data has to be, kind of the use case, what kind of operations do you need to do with the data? Is this something like you have to aggregate a model from a stream? Is this something like I have just to store simple data that comes in and you pull out again? Is this something where you do rather like graph queries, like shortest path or something like that, or lots of deep trees? I would probably come more from the use case than just what the team knows, because otherwise you kind of get stuck with the stuff that you used in the 70s. And also it's an opportunity to learn some new things as well, right? Our industry is evolving really quickly, and if you just go with what I know, then you'll also lose an opportunity to learn some new stuff, which might be a better fit than for your next project as well, right? So it's that opportunity that I think is important.
So obviously I'm biased, but I've seen Kafka used as a very good platform on which people evolve their choices. So starting off with Excel, and I went to a great talk a few years ago, and a company were talking through their big data journey. It was the buzzword at the time. But they started off, and they literally were using Excel as their source for the data. But they were routing it through Kafka down to some other system, which again was like no better than just like a VBA type hack. But then, because they were using Kafka to interchange the data, they could then build on that further. So then the year later, they moved away from Excel, and they were using, I think they were using HDFS or something, and then they were using, instead of Visual Basic, they were using Spark, but it enabled them to actually mix and match as they wanted to, rather than having to kind of maybe prematurely optimize and say, all right, we're going to go for super shiny tool over here, or this over here, and we don't know if it'll scale, but hey, it's what we know. Actually saying, well, we're going to exchange our data, we're going to use Kafka as the basis for the information comes in, it goes onto there, and then we can route it to wherever we want. We can actually route it to Excel and to this database and this other one and see how they all perform side by side. But you've got the data that resides in Kafka and can actually be used multiple times and hooked up to the different systems. So it gives you that flexibility on which to build. You don't have to make your design decisions and stick by them up front. You can actually say, actually, we're going to see how things go. As Michael says, technology evolves so fast. You've no idea what technology is going to be around the corner next year, what volumes you're going to be dealing with. You might think we're going to be kind of like the next Netflix, and we're going to do distributed, we need to cope with like 10 million petabytes a minute or something, but maybe not. So if you over-optimize early on, you waste that opportunity. So using something like Kafka as a platform for your data enables you to switch out where you bring it to and from easily.
I would just only add one thing. If it's a greenfield project, that's what you said in the end, you really need flexibility, and that's, I think, the key factor that you should take into consideration. So being able to very quickly change the technology, maybe the data model, maybe extend it, etc., etc. This is really important, because too often we do table-driven design, and we have our customers talking to us, and we model the tables in our heads already, and we just sit down and model it in whatever the SQL database or NoSQL database we have. This is not about that. This is about creating value for the customer, and whatever. If the customer has very well-defined project and the value that they want to get from the project, that's much easier. But tell me, how many times in your lives have you seen a customer that told you, this is what I want, and this is the business model that I will be using for another 20 years, and we will be fine with that? Apart maybe from some government agencies, but these are, of course, bloated projects that never end.
Okay, you asked for migrations. So the question is migrate data from SQL to NoSQL and vice versa. Is there any use case when it's necessary? So I would like to extend this question. Have you, or maybe you, some experience where decision to go for example, for NoSQL was a very, very bad decision and you had to roll back because it was very, very wrong decision?
I think I can start. We have a very large.
I know they are very, very experienced. They don't make a bad decision.
Yeah, so I can make a bad decision. We have a huge monolith SQL database, and that is monolithic to the whole application, and we're trying to slice it, but by slicing out the responsibilities and model the data in this way, so in the context of the processes that we have. So I think we missed, as a company, we missed this quiet moment when your database does, and this is the moment that it was too late to actually do this right. It was too large, too many queries per second, etc., etc. And now we have to very carefully slice it in a way that we're still operational, everything is fine, customers are super happy, everything is optimized, but we have a different data model that allows us to actually extend the platform.
Yeah, so migration is pretty straightforward, right? So you basically you see what data you need in your new database and fetch it either directly from the relation database or from something like change data capture to keep it in sync. For migrating back, I think I've seen more people migrating to a different NoSQL database than back to relational, except for Postgres. So people love to go to Postgres. So you always have these like blog posts where someone bashes Mongo and says Mongo is shit, and we just move back to Postgres because it does everything better.
Why they decided to migrate to another different NoSQL database?
There are different reasons, right? So some is that certain operational characteristics are not working out. That it takes too many machines or too much effort to do something, for instance. Sometimes NoSQL databases go away, like you've seen Riak die, or RethinkDB, for instance. Others are acquired, like Apple bought a bunch of FoundationDB, for instance, and they completely go invisible, right? So then you're kind of forced to migrate away. Sometimes it's also something like a new CTO comes in who has a different background and thinks that his background is better, and then there are also changes like that. And sometimes it's just politics, right? So you have a database vendor going golfing with your CEO, and then there's a decision, we're going to switch to IBM or so, right? So and then
or there are investors, and they say Hadoop, Spark, Kafka. You need to have that, and AI, of course, and blockchain.
Yeah, kind of buzzword-driven development, right? So that's kind of, and also the technology evolves, right? I mean, Hadoop is a good example, right? So where you said, okay, initially everything was in Hadoop, right? And then Spark came along, moved it into in-memory, not file system anymore. So people migrated stuff, their Hadoop workloads into Spark workloads, right? When the next thing comes along after Spark, right, whatever that is, then we'll migrate from Spark to somewhere else, right? And that's kind of just natural, right? And actually, it's an interesting bit if you think about it, how much of our old data is still accessible in the old systems, right? When will we not be able to run as something like, I don't know, FileMaker or DBase anymore because we don't have the environment or have to run it in an emulator or so to get access to the data, right?
I think there is one interesting aspect that you mentioned, because looking back, I think that one thing that has changed recently is how much data do we need to keep in our systems to build better systems. How much old data do we need to keep? So very often we only operate on the data that is very, very hot, and we don't need all of that old, just maybe even cold data. And also there are some legal requirements like GDPR that requires us to delete that data, and especially with lots of streaming platforms and streaming requirements and machine learning on the fly, you just don't need a lot of the old data, but you need a wider spectrum of data. So this is also an interesting paradigm that we're entering over the last few years.
Actually, I just had something for all of you as an end user. What I actually like today is oftentimes the data is much more valuable than the platform or the application, right? And that's why if any of the platforms that you use, be it Facebook or Slack or others, allow you to download your data, it's first of all, it's very interesting to see what they stored about you, and secondly, you can take this data with you and move it to somewhere else, right? So that's something that we've done quite frequently, just to take data from LinkedIn or from Facebook or so and put it into the graph. Or we even do it with Trello, because Trello's search API sucks really a lot, and so we just import all the data, take the data from Trello and put it in Neo4j to search for certain things, right? So stuff like that. So you should be flexible in terms of saying, okay, I need to have this kind of functionality. I know this kind of database offers it to me. Here's the data. I have some kind of import or migration script and pull it in, and then can use it in new ways, the same data, right? Or even have it in two places.
Yeah, you touch interesting topic. For example, NoSQL database org website, we've got over 225 databases reported. So how we can live in this world? So because when I've got SQL, so for example, every single person can use my database. When I've got a NoSQL databases, there's probably a completely different interface and completely different operations for some teams. So how we can live in this world? So we have a discussion with Wojtek a little bit earlier about a unified interface for at least some databases. But maybe you've got some thought about it.
So I would just elaborate on that conversation. So our conversation is, I think, the beauty of SQL, and we're getting away from the technical implementations or whatever the database you have, is that at the moment SQL is everywhere, just as we said in the beginning. So if you know SQL, no matter what database you will use, of course there will be some details in the optimization, some differences in because there are some functionalities in one databases or data systems that doesn't exist in the others, etc., etc. But this fact alone that you know SQL is actually allowing you to do pretty much everything with your data at the moment. And this is the shift that we've seen many years ago on how to use HBase, for example. At the moment, I haven't met for a long time somebody who uses HBase. Everyone uses Spark, for example, and Spark has SQL, and that gives me ability to actually also shorten the time required for the team to prototype, which is great because I can invite a wider spectrum of the team members to use whatever technologies they want, and with whatever kind of a data we have, and let them play with it. So it's not limited to some magicians that do big data certifications. It's for everyone, and I think that's the beauty of this world. It's actually, I wouldn't call it mad. This is getting back to the normal.
Yeah, it's an interesting question. So regarding the databases, it's basically looking at your ROI. So if you get a big additional value out of using this certain technology, then you have to invest also into using it, right? So you make a choice, you say, okay, I get like 10x better performance or that 10x better data consistency out of this database, but it's a new thing, so we have to invest into learning how to operate it, how to run it, how to query it, and so on. And if it's worth it for your project, then it's worth it, right? So the biggest challenge is to make this selection in the first place, right? From the 250 databases, which one are the good ones? Regarding SQL, I'm not really sure that it's always the case. Actually, what's quite funny is Neo4j, as a quite small company, is now working with the SQL Standards Group and Oracle and some other database vendors to build the first new query language, which is the graph query language, which will live in the future side by side with SQL, basically, as something that they've never done in 30 years to do a new query language. So that will be fun. So as standard committees are lots of fun. That's something that I'm looking forward to see what happens there. And then the other question that I would actually have for all of you is, what is actually the SQL skill set? When you listen to Lukas Eder, for instance, the author of Joke, to talk about like the skill sets in SQL, like everyone can do select from, where, group by, order, limit, skip, right? But what? Stream. Yeah. So, but what's with window functions? What is with statistics and database aggregations? What's with common table expressions? Like all the JSON stuff, spatial, date and time, and So there are so many aspects on in a skill level, right? We can all write our select, but where does it stop? Who of you can easily write commentable expressions? Right, I can't. So 3, right? Who can do like all the aggregation, window function statistics, stuff like window over partition by stuff, right? So that's a problem. The power
don't be shy.
No, that's really a problem, right? So the power of SQL is there, but it's actually not as widely spread as we think it is, right? And that's kind of something that I see as a problem there. Right?
But I suppose with that, those additional things are built on top of what people do know. So like partition by and stuff like that, I used lots in former role. I always had to go and look up the syntax, but it was simply adding to the existing stuff. Whereas new languages or new APIs or whatever, you're starting from a base of 0 with it generally. So
okay, so the question to you, Robin and Michael, what are the biggest challenges right now for Kafka and Neo4j? What are your teams working hard now on?
For Kafka, well, I think the challenge for Kafka is getting people to understand that it's not just pub/sub, that it's not just data ingestion, that it's actually this concept of a platform on which you can build, that you can do integration with other systems, that you can do stream processing within it, and because people can do a lot more with it once they understand that. So that's kind of the one of the challenges faced with it. In terms of what we're working on, there's a lot of effort going into Confluent Cloud, which is our Kafka as a service offering. There's stuff that we're doing around running it on Kubernetes and the kind of the cool stuff around that. So that's some of the things.
Yeah, for us as well, one big challenge is still educating people about graphs. So that's still something that's to be done. Now there are many more vendors doing it, so it's easier for us. In terms of the product, or in terms of the ecosystem, it's kind of building this new GraphQL language is one big effort as well. And in terms of Neo4j as a challenge is sharding scale out, which is a non-trivial problem for graphs, and graph compute, which are things that we want to invest a lot in next year, and Neo4j Cloud as well. So that's another Kubernetes operator for Neo4j.
Yeah, I think, Robin, we've got a special question to you. Is Kafka going to work on performance on Java client?
Sorry?
Is Kafka going to work on performance on Java client?
So Kafka is an open source project. Feel free to join in on that. Performance is not something that I often hear raised as a concern with it. So there are various different settings around it. I'm going to have a chat with me afterwards or send me an email. There is a really good Slack community around Kafka and Confluent Platform where you'll find a ton of Confluent staff, kind of Kafka community, and people who may have hit the same kind of issue. There's also the Kafka users development mailing list as well on Apache. So I'd be interested to hear more about that.
Yeah, the one question is on the way. I clicked, but there's no, wait a second. The question is Aaron considered a competitor or something that can help Kafka?
I'm not familiar with Aaron. I've not heard of that. So I guess no.
So I think we are almost out of the time. So the last question, don't you think that when NoSQL hype will be gone in a few years, we'll back to relational databases after all?
No, definitely not. Because so from my point of view, relational, NoSQL, whatever, it's an abstraction above events. Events, I think more and more people are realizing that events are what our data is, what data is made up of, both the power of using event-driven architectures, but also simply using events to connect our systems as a way of, streaming is not just about real time. Streaming is about unbounded data, and almost all data is unbounded. So I think take away NoSQL, take away relational, that's just where do you want to land it, where do you want to store it. But data exists as events, it's born as events. So I think more and more people are going to realize that you use a streaming platform on which to build, and then you kind of go and store it wherever you want to.
If we would have secure as event sourcing advocate, that would be an interesting discussion here. But I think we stick too much to what is currently on the hype, And if you look into the future and trying to guess what will happen, I would say this is definitely real-time systems and machine learning. So, and this is no escape from these both. So from my perspective, what is coming back to relational databases? Because from my perspective, whatever delivers these two, so very fast, almost real-time analysis, and can automate this process for you using machine learning and AI, this is the future. And this is something we should be all looking into. And so whatever you feel comfortable with, start playing with it. Because we can debate on whether it's a Mongo or a MySQL or whatever, but the future is very, very different, guys. And it's not about I mean, it's also about building a very complex data systems where you will have part of your data, as we discussed, being stored in some kind of a relational database, part of it being streamed, and all of that being connected by pipelines of models working with all of them. And on the side, you will have your data lakes. Whatever it will be, a huge FTP with Excel files, or HDFS or big table. It really depends on what you feel comfortable with. And it will be all okay. But I think this is what is truly important in the future. It's the real time and machine learning, and this is, I think, this is the future. And knowing, observing where all of the technologies, the data technologies go, knowing SQL, you will have access to all of that. I wouldn't be surprised if there will be a project coming out soon where you can build your models using SQL. Why not? You can do it now with Python. It's just another way of expressing the same mathematical description of the model. So why don't, instead of, 5 years ago, if I told you there will be a create stream SQL query, you would tell me you're nuts. What if I tell you there will be a create model query coming out in the next few years? So I think this is the future. So a big ecosystem of different technologies that are united with one probably querying language with some differences. That allows you also one very important thing from my perspective: quick, fast prototyping, because that is very important from a business perspective. So business, most of the businesses need our help from us as IT, and they need our help in being able to actually build something very quickly, check it on the production, see if it's working. Is it everything that we wanted? How our customers are feeling about it? Run A/B tests and all of that stuff. And if you have a stack that delivers that, this is really important. The rest is implementational detail.
Yeah, which is a good question, right? I mean, the NoSQL movement came about because relational databases were not up to the job, right? So I think, for instance, DynamoDB at Amazon was built because Oracle couldn't cope with the load. And so I think it will stay the way that there are different tools for different jobs, and you should pick the best tool for the job. If it's a relational database, it's a relational database. If it's a graph database, it's that. If it's a string solution for that job, then that's the best solution. And that choice will stay with us, I think. I don't think it will end up in like going back to Oracle can do everything and you just pay your $2 million for Oracle or whatever, right? Or Postgres can do everything and you do everything with Postgres. Because that's sometimes also forcing kind of the round peg through the square hole, just it has to work and we have to make it work, and no matter the cost, basically. Where the cost is not just money, but also effort and time and maintenance and so on. So I guess, so for Neo4j, we always said NoSQL meant not no to SQL, but not only SQL, which I think is much better description than like this war aspect, because I think there doesn't have to be a war, because we're all there to serve our users, our customers. Developers should be happy and should have fun building apps, and that's what kind of all the vendors should kind of focus on doing.
Yeah, so there was no war after all. so thank you very much for your time. Thank you for your questions. So I think they deserve a big applause. So thank you very much.